Swayam Prabha. Digital India. Educated India.
Okay, so I want to continue our discussion that in the last few classes there are two themes we discussed. One was about sustainability, what it means, what are different aspects of sustainability, and how we think about sustainability in a global scale, in a product level, so and so. Okay, and later on we said how we depend on materials. Okay, material dependence, what sort of material we use, how much we consume, and what are the impacts. And then through civilization we looked at several ages of material dependence, and we are living in a time of plastics. Okay, when we say age of something, when we say age of stones or age of steel, it means that many of the products we are using in the contemporary time are made up of that material. So when we say age of plastic, it basically means that very large number of products, materials that we use in our daily life are made up of plastics. Okay, so that's what it means. Okay, and it is not an overemphasis. Okay, so we can, it's obvious that we consume a lot of products which are plastic based. So what are the problem with that? Is it good or bad? What is it? So I wanted to basically leave you with a couple of questions at the end of this lecture to think about how we should look at these plastics. And in this lecture I want to give some more information, some more discussion related to just plastic alone. Okay. So if you think about plastics compared to other materials, right, like metals, wood, okay, compared to those, plastics are more like newcomers. Okay, we have been only using them the last 100 years or so. Okay, so in the time scale of other materials, one can say that plastics are newcomers. Okay, so what that means is we are not very sure about to say good or bad about plastics. Okay, because our interaction with plastic has been only 100 years. Even though 100 years looks longer, but in relation to other material use throughout the civilization, this time scale is still shorter. So we can safely say plastics are newcomers to our lives. Okay. Now another thing we notice is that the plastics are very cheap compared to other alternatives. Okay, so if you want to make a water bottle with plastic versus a steel bottle, so clearly the cost of plastic bottle is cheap compared to steel, right? But at the same time it is also better. What do I mean better? Well, the water bottle plastic made is far more lighter than carrying a steel bottle. Okay, many times I have tried using a steel bottle in my backpack where on the side there is a pouch. It's very easy to fit in a plastic bottle comfortably, but the moment you put a steel bottle, you see that it's tilting, it's falling down, it's too heavy, it's very inconvenient. So plastic in that sense is both cheaper, also better than their alternatives. It's also one of the broader statement one can claim, okay, across products. Take automobile. Okay, instead of making all of them based on metals, if you can make few components with plastic, you make lightweight, fuel efficient, right? So cheaper, better. So you can, it goes hand in hand. Now the plastics in our modern life, as I said, there's no brainer. It's everybody understand. Your laptops, your mobile phone, case, pens, all the objects you look around, you see, are made up of plastics. It has become a mass scale, everyone can afford, right? So it has become really something that all products could be used for all people. Okay, and the picture that is shown here shows how social impact the plastics have made. There were times where people used to carry big metal containers or potteries to fetch water from one distance to another distance. Now in the coming of this plastics, it has made so easy for them to carry water from one place to the other place. Okay, so it has reduced people's burden in terms of bringing resources. So it has made true impact on people's life, right? And another thing is that unlike other material, plastic is something you can easily mold in various shapes. Okay, you can melt it, mold it, put it into a casting die and take whatever shape you want, and you can make them colorful also. Okay, so think about it, it's like a dream material. You want them cheaper, you want them to be moldable, and you want them to be better. All boxes ticked for plastics, right? So therefore, we say that, you know, compared to other materials like stone, copper, bronze, steel, we live in the age of plastics, okay? And these are all some of the positive points you can make to say why one should use plastic and why we are being using plastics, okay? These are all genuine reasons that that's how plastics have made into our lives. So what that means is, the more and more you consume plastic in more and more newer products, the production of plastic will also go up. So what is shown here, I don't know if you can see from the back, these are given in terms of millions of tons, okay? 100 million ton, 200 million ton, 300 million ton, and so on. On the bottom you have years, okay? Starting from 1950, where we started consuming plastics. Here we are somewhere about 2019. The data shows that we have been producing something about 450 million tons of plastics per year. These are not cumulative numbers, these are per year productions. So everything that was produced previous year keep accumulating, right? So this is our annual global production rate of plastics of all kinds, okay? So you can see that the increase is you know, very steep, okay? It only says that we have become a complete consumer of plastic. We cannot leave the dependence, right? So it has become so ingrained. And here I have tried to give some distribution. What do you mean by plastic? What kind of plastic we have used? So this is a report from the OECD. So this bar here is the production of plastics in 2019. Based on this, they have made a projection what would be our consumption of plastic in 2060, right? In about 40 years from 2019, okay? And in 2019, about 460 million tons of plastics were produced globally, and this number would actually go to 1,230 millions of tons, okay? Almost threefold increase by 26. This is a projection that has been made. Now, if you look at the color code, so each color corresponds to different kind of polymers, okay? Of the total 460 million ton of plastics, about 16% of them are actually polypropylene, okay? So PP here means polypropylene. About 16% of the total plastics produced are polypropylene, okay? Polypropylenes are used for many things, including the cap that we use for plastic bottles. Then about 12% are LDP, low density polyethylene, okay? Something that we make the milk packaging, for example, right? LDP, LLDP, these are about 12% of them are polyethylene, and fibers some 13%. So this fiber can be nylon or many other synthetic polymers, okay? Then we have HDPE. Here HDPE is a high density polyethylene. It gives much more durable plastics. For example, pipes are made with HDPE, okay? Sometimes even the bottle caps are HDPE. HDPE means high density polyethylene, okay? Then we have polyvinyl chloride, PVC, which is about 11%. PVC is again mostly used for pipes, okay? Large number of use is found in pipes. And then PET is nothing but polyethylene terephthalate, used for bottling application, beverages, water, various other fluid containers. And then polystyrene, polyurethane, styrene, acrylonitrile, and others, or other smaller components. But if you look at all of them, broadly speaking, the usage seems to be dominated on packaging, okay? Of all the plastic that is generated, about 30% are used by, 1/3 almost is used for packaging. And packaging is one thing where we are going to use it for a short time. The moment we use a product, the packaging is discarded, okay? So we consume a lot of plastics for packaging applications, and we don't want them to be useful for very long. It's only until the product is opened, whether it's a primary, secondary, or tertiary packaging. If you're buying a biscuit packet, the moment you open the packet and you consume the biscuits, the packaging is useless. You're going to just throw it away. No use, no further use. On the other hand, if you buy a toy which is made of plastic, you can actually use it for quite some time. Few years you can you can play with it. You can, if you have a Lego for example, you can use it for quite some time. Okay. So compared to other applications, the packaging application has the shortest life. The moment the product is opened, it's not useful. So that seems to be the largest consumer. Then we have construction about 16%, transportation about 14%. When we say transportation, we mean automobile and many other automobile parts. Consumer products, okay. A lot of consumer products do use plastics and polymer applications. So all this color, what it means is, so here right now all this color corresponds to different plastics, and then in 2060 each of these component will be produced in large scale and more 3 times more. And then suppose if you take the blue one, so the blue one means polypropylene, and here it shows how polypropylene used in various applications. For example, if I take the top one, it means usage for packaging, and if I take this one, this is used for okay, I think all of them are actually packaging. This is packaging, so this is construction. So if you look at all the blue band are polypropylene used in various cases. Majority of them used in packaging, some used in construction, some used in consumer products, and some in vehicle, and so on. So if you follow some other color, for example, if you follow the pink, which is HDPE, you can see HDPE is found applications in packaging, also construction, consumer products, vehicles, and so on. Okay. So we see that many of the materials that we are using will find applications in other kinds of applications too. Okay. So that's a bottom line, and these are the acronyms here, what I meant as PP, LDP, and so on. Right. So okay, so what is the thought process? Sustainability, material dependence, plastic dependence. How much plastic we produce, for what application we use is evident. So I ask, where are these plastics coming from? What are the raw materials for plastics? Right. So if you are making 460 million tons of plastic per year or more as we speak now, where are these coming from? How are we making them? Okay. So then you are asking about, okay, what is the raw material for plastics? Okay. So if you think about raw material for plastics, these are currently based on fossil fuel feedstocks, okay, including crude oil, that is petroleum, natural gas, coals, etc., which are all non-renewable fossil fuels, fossil sources. Okay. We know that most of them are actually useful for fuel application, but we also consume quite of this for making plastics too. Okay. Of the total crude oil, natural gas, and coal, about 4 to 5% are used for plastic, the rest for fuel. Okay. And we have a similar discussion going on in fuel sector too, energy sector too. How do we sustain energy when the fossil fuel run out? We are talking about material property, material dependence. There is the energy security, there is the energy dependence parallelly going on. But this course is about material and plastics, so we are confining only plastics. More larger issues, more concerning issues are being discussed in the energy sector too. Okay. Now coming back to the material world, plastics are made from feedstocks, and you will see that the plastic production and oil productions are correlated. Okay. More the oil produced, more plastics you can make, and vice versa. Okay. Because of the fact that it is dependent on the fossil fuel. Now if you think about what is the availability of these fossil fuels, it seems coal is something more abundant than the other. Some predictions say that we will still have coal deposits available to us for the next 2 to 3 centuries. Okay. So that is based on what is known about the current deposits and how much we can access. But if you think about the petroleum and natural gas, prediction shows that we can probably have another half a century, 50 years or so from, we can extract petroleum and natural gases, and after 50 years they don't meet source. Okay. And another thing is, even though we say coal is available for the next 2 to 3 centuries, it doesn't mean that coal is evenly distributed for all of us. Okay. When you think about the entire countries and how they are distributed, the coals are distributed differently. Okay. Coal deposits are available in one place over the others. That means countries which do not have coal deposit will have to import. Okay. Then you are basically dependent on others' willingness to sell to you. Okay. So, this uneven distribution of resources is another concern. Okay. So, for example, Qatar has a lot of oil, it is a rich country, it can distribute, but if Qatar decides not to sell, then there are so many countries which depend on their oil sources will be hampered. So, how do we handle such situation? So, these are some of the facts, and why we are saying this all, because it seems plastic is something that we are going to consume, we are being consuming, and their production depends on all these natural sources, fossil resources which are non-renewable, and if we run out of this, we will not be able to make plastics. Okay. So, that is one constraint that we have to keep thinking about it, right. So, now I am taking to a different situation now. So, what we are saying is plastics are useful, we are making a lot of plastics, and where we are making from, that point is made. Now, let us say we have made plastics, and what do we do with them? Okay. So, we are talking about use and disposal. So, when you think about this, this is a nice plot, I got it from McKinsey's report. If you look at the gray ones, these ones tells you about how we manage post use of plastics, post consumption period. Okay. So, for any material we have production, use, disposal, we have 3 phases. So, we saw how they are made from what resources, and now we already saw what are the applications we can use for packaging, we can use for construction, transportation, personal care, etc. that is use. Now, we are talking about disposal, and what is the current trend? The current trend seems to be that about 40% of the plastic after use are filled as a landfill. Okay. If you have gone to this Perungudi dump yard and other places, you would have seen large mounds of plastic and other waste being dumped. Okay. And the number of such landfill sites are also a concern. You can't live nearby, it has a lot of other consequences which I will talk about now. Okay. So, landfill is not the preferred choice. We do landfilling just because we do not know what to do with it, right. What else we do? We also incinerate. About 25% of the plastics are incinerated. Incineration, what it means is you are basically burning it off. Maybe you can make some energy out of it. Okay. You are burning, you will produce some heat. Through heat you can probably generate some electricity, maybe you can consume some energy, you can probably produce some energy. Few municipalities are doing that. Okay. But one problem with that is that if you are not sure what you are burning, you do not know what gases you are sending to the atmosphere. Okay. And you may be actually polluting the air more than the soil by landfilling. So, you have to be very, very careful, extremely careful what you are incinerating. You can't just randomly incinerate all kinds of plastics. For example, if you do PVC you should not be incinerating, because PVC has an additive, okay, called flame retardant. It is a bromine based content, and then if you incinerate it, you are going to put a lot of bromine on the air. Okay. And that gives a lot of breathing issues and air pollution. Okay. So, you should not be incinerating PVC, and there are also many other plastics with many other additives that you should be very careful. So, incineration is not, in fact in Europe incineration is not preferred. Okay. They are looking at alternative methods of converting this plastic into something else. Recycling is one option. Recycling basically means that you take the plastic and then add some value to it, make them into a monomer, or make them into a something reusable for the same application or downgraded application. For example, PET, polyethylene terephthalate, is the most recycled plastic of all. Okay. And there are several plants within India and outside India doing recycling. Now, when you recycle, you will compromise on the quality of the plastic. When I say quality, the polymer chain becomes degraded, it becomes smaller, shorter. You can't use it for the same application you used before. So, you need to do some further processing. If you are not willing, you are going to put this recycled plastic into some other application. For example, in India, you would have seen many newspapers saying that PET recycled clothing, textile. Okay, the textile fibers are actually low grade PET. The high grade PETs are used in bottle applications. So, you take a bottle, plastic bottle, PET bottle, recycle the PET, put it into textile application. This is a downgraded application. Okay, but the real aim should have been, if I can put back in the same PET bottle making, so that I can depend less on the virgin plastic. Okay, so that is a true objective of recycling. Okay, this is where a lot of technological development will have to happen. how do I ensure when I do recycling, I am not compromising on the polymer property, so I can put it back for the original use, not for any downgraded use. Okay, so that's where a lot of R&D will be required. So you can see that some 16% are recycled chemically, mechanically, whatsoever. And what is very alarming is about 20% of the plastics are actually unmanaged. When you say unmanaged, you are just throwing it away somewhere, consumer just throwing it away, and we don't know what's happening to it. But we do know that all this unmanaged plastic ends up in river bodies, ocean, lakes, which also affects the marine life and aquatic life. Okay, and this is very, very dangerous. At least landfill, we know there is a landfill site, we can say nothing to be done around that area. At least we can have some precaution. Okay. Similarly, incineration and recycling, we have managed them, but the unmanaged one is the most important issue, okay, because we don't know what they are going to cause. Okay. So going back, what we are saying, sustainability, material dependence, age of plastics, how we make plastics from fossil fuel and their dependence. After we make them, what we do with them, we are going to use for various applications. Once we use them, we are going to discard them. In the discarding stage, we have these options: recycle, landfill it, unmanage it, or incinerate it. Okay, these are the options. Okay, and this we have been doing for a very long time. Okay, most of us, we are doing landfilling and unmanaging. Very recently, the recycling and incinerations are happening in the last few decades, maybe. Yeah. So that's this life cycle: virgin feedstock, polymer production, do application, and create waste. And how do we manage waste? So now I'm looking at now what are the consequences of this unmanaged waste. When you do landfilling, when you do unmanaged waste, what has been the consequence, and what kind of data is available today from those unmanaged wastes? Okay. So now in the last 20 years or so, a lot of research has been done on the presence of microplastics, tiny plastic materials in various forms. Okay. It is found that there are about 6 major sources of microplastic production, and all these 6 are related to our activity, our human activity, how we consume, how we behave. Okay. For example, we use many of these macroplastics based on bottles and packages and other things. We also do a lot of painting of ships and houses and many things. So a lot of microplastics are emitted through these kind of painting applications, plastic pallet making, synthetic textiles. Okay, many of us use synthetic textile, and we do washing. Washing machine produce a lot of fibers, microfibers and microplastics into the water medium, water stage. Automobile tires. Okay, if you have ever seen a landing plane, you will see a sudden bloom of microplastics. There's a huge, because of friction between the tire and the runway, a huge amount of plastic is generated. And so are the cars, heavy vehicles, when it goes through. So all this microplastic is going to be on the air, right? And of course, personal products, cosmetics, various other products also has microplastic in them or plastics in them, and they also. So all these 6 human activity are known to produce tiny particles of plastics. Okay, and here someone actually measured the leakage by various sources. So you can see personal care about 57 kilotons, plastic pellets 554 kilotons, tires close to 1000 kilotons, and then the major seems to be the macroplastic that we use for various toys and furniture and construction material and so on. So, okay, so many of the human activity that I am talking about are known to produce several kinds of microplastics. Just peels off. If you think about a ship, the ship is coated for anti-corrosion and anti-biofilm formation. Okay, so they paint the surface, and these through time they weather, and small pieces of plastic comes off, right, and that releases into ocean. Okay, and you think about the number of ships that are sailing, a number of fishermen boats that are sailing, all of them are painted for corrosion resistance and anti-fouling, and that's a huge, yeah. And there are, so this you should all read this paper. This there's a paper in Science that came in last year 2024. This paper summarized what we learned about microplastics or plastic particles in various scenarios in the last 20 years of research. I think the first report was presented in 2014, where they found in ocean water small nylon fibers were found in small sizes. So since last 20 years, a lot of research happened, and this kind of summarizes. If you think about it, mountains, land, water bodies, in all these microplastic presence were measured and quantified. So here there are papers on looking at how much plastic is present in Mount Everest. Okay, how did plastics end up there? People who went on mountaineering or trekking would have also microplastic present in the air can also get deposited. Okay, and atmosphere also you can see a lot of plastic. So the units are different depending upon whether it is a land or ocean or soil, but you can see there are numbers that are being printed. There are plastic present in seabirds, agricultural land, soil, river, shoreline, sea surface, ice, deep sea water, deep sea sediment, lakes, and so on. Okay, so there are a lot of reports. So all these the number that you see in the bracket, those are the references cited in the paper that has kind of summarized various quantification of microplastic in the various things. And what we are saying is, whatever the plastic that we did not manage, we just discarded them, have ended up into formation of microplastic, tiny plastic particles distributed all over the the mountains, the air, atmosphere, and ocean, etc. So this is a little bit of a classification that there are plastic that are more than 5 mm, less than 1 mm, and less than 0.5 mm. And these sources, for example, if you look at the tire and personal care application, they are found to form plastic that are less than 0.5 mm. Okay, and if you look at the synthetic textiles and pellets, they end up making this small fibers, textile fibers of the size of the order of less than 1 mm. And macroplastics like bottles, containers, and various things are known to form plastic pieces more than 5 millimeter. Graphically it is shown here, and they also shown which kind of plastics are found in which kind of organisms. The most tiniest plastics are mostly found in the smallest organisms, right, like Daphia magna and small diatoms and so on. And also other fish, marine organisms. The one that are about sub-millimeter are found in fish and birds, and large pieces are found in cows and even human bodies and larger fishes also. Okay, so basically the entire life have been affected by the presence of plastic of various sizes. This is a little bit more scarier image. This shows people have reported how much plastic is present in our own body, humans. Okay, so they've looked at all kinds of samples, right? Hair, saliva, sputum, blood, breast milk, liver, kidney, inside, outside, microplastic have been found. Okay, even including placenta. And if you ask how they entered in our body, there are 3 mode. We inhale microplastic from air, right? Sometimes we take it from food. We consume food that is packed in plastics. Okay, Zomato, all of you are ordering Zomato, right? Are they selling it to you in a metal container? They are selling it in plastic container. And you like hot food, right? You want hot sambar, right? You want hot dosa. Okay, and next time when you order, think about it. Home food is always good, but you cannot cook at hostel. So okay, so we get a lot of microplastic from food, how we consume food and what we consume food, and then also dermal absorption. We apply a lot of cosmetics, right? All of you apply cosmetics, sunscreen, lotions, and a lot of plastic in there, right? So we can also see that dermal absorption of microplastic. These are 3 different modes of how plastics come to our bodies. Okay, and then gets in inside our body everywhere. I used to jokingly say that you can say that there is no microplastic in a particular place in your body just because you have not tested yet. Okay, if you test it, you will find it. That's, I have never seen a report saying that, you know, we took some sample from this and we didn't find microplastic. No, it's always a positive. There is always some plastic available. But how harmful they have been, that we don't know. Okay, we don't have a very major risk yet. We have not been able to say that because of microplastic in our body something happened. We don't have that data, but doesn't mean that we can wait until that happens and then take action. In medical public health, there is always a anticipation. There is also a presumption that what might happen when you are exposed to too much amount of something. Okay, like for example viral, some amount of viral is okay, but the moment you exceed the threshold, then that's where you see some symptoms and effects, right? Similarly, microplastic can also be something. Okay, another thing they say is that since microplastic most of them are hydrophobic, it can attract other hydrophobic toxic substances. Okay, it may not be just pure plastic. The plastic may actually come with some toxins also, and if you consume that, plastic as a carrier may not be toxic, but what it brings as a substrate can become a toxic. So there are a lot of things we have to be worried about, right? Okay, I will not scare you with too many details on this. I will go on further. So the question we are asking is the following. Okay, you know, the first question is, okay, we depend so much on fossil fuel for the manufacturing of plastics, and fossil fuels are finite and we are losing its deposits. So now if we were to produce more plastic as we need, where are we going to turn into? How are we going to manage the raw material needed for plastic? So that is one broader question we should ask. One answer can be, maybe we should look at nature based raw material, biomass, agro waste or agricultural products, which we can make them renewable. We can produce them as much as we want. So can we make plastics from these renewable biomass? Can we do that? Okay, so that is probably one way of thinking about this. So we don't have too much dependence on the fossil fuel and its exploitation. The second question we ask is, how do we manage plastic wastes so that we actually impact the environment as less as possible, as minimal as possible? Okay, so here we have several options. We can create awareness on use and disposal of plastics. As a citizen, you know, we should be very, very conscious of how much to use and how do you dispose. Okay, some sort of a social awareness, social drive, something should be done. We can also work on, this is where we can come to play a role as scientists, as researchers. We can come up with the recycling technologies. Whichever plastic we use, we should have a number of recycling technologies that is cost effective, that add value to the waste and put it back in the in the production, right? So there is a huge scope from a research point of view in this. And then also, how about, you know, switching to a biodegradable plastics, if not for all, for some of the short usage plastics. For example, packaging, as I said, requires only a short lifetime. Can we think of biodegradable packaging only for packaging application? For durable plastic, you may not want that biodegradability because you want them to durable, you want to sustain for long. So it seems that multi-pronged approach is probably required to manage or mitigate the plastic waste issue. Develop more recycling technologies, try to develop alternative bio-based biodegradable plastics for some application, if not all, and then also create awareness as much as possible in dealing with plastics, right? So these are just my thoughts. You can think about it. We can probably have some 3-4 minutes of discussion to answer this question. If you think plastics are good, bad or ugly, open up and say something. You want to go first? You want to say something about, what do you think? You want to come here and just tell your friends? You can use the mic so that the recording happens. No, I think they're recording, so if you want to speak in this, you'll be recording.
So in the environmental point of view, it's a very good material, but sorry, in the application wise, it's a very good material, and in the environmental wise, it's like it's a worst material. Like we should very conscious about what we are disposing and how we are segregating, and we should be more aware of what we are doing.
Be more aware.
Yeah.
So you are saying they are good, bad, and ugly, not or. You're saying they're not. You can't say they are good, or they are bad, or they are ugly. You can't say that. You can say they are good as well as bad as well as ugly. Is that what you're saying?
Yes, sir.
Okay. Okay. Good. Thanks. Maybe I should have posed this question first before telling all this. I think that's why you're all now very balanced, and you say, yeah, you know, they are good, they are bad, they are ugly, depending upon. Any other thoughts? Any other anything comes to your mind that is that can add more to this discussion? Aradhana, you have something to say? It's good. Mm. Mm. Right. Mm. Right. Okay. Okay. So, if no further thoughts, we will stop here. And next class, I will. So now you know we understand. So we looked at all aspects of you know very broadly without much specifics. Okay, how much we make, where we make from, how do we dispose, and what are the consequences as of today. Okay, so that should be clear to you. Okay, if at all you take anything from this course, just this lecture. Okay, from now on we'll dive into some specifics like you know what polymers are, what plastics are, how they are made, what is the chemistry, you know, what is biodegradable means, and how do we process them. Become very technical from now on. Become more and more technical. But till now, whatever we discuss is a very global level, picture, very top level understanding. So it's very important that you understand these three concepts: sustainability, material dependence, age of plastics, and what it means to be in the age of plastics. Okay, those three things you should keep in mind, even beyond the course. Okay, anything else you're going to learn is more specifics. All right. Okay, so we'll stop here and meet you in the next class.